Okay, so on this next one, it's asking us to do the exact same thing. Okay, so if we go to E, it says, if I know the angle BCD, okay, so it's this angle right here, so angle BCD, plus this angle of ABC is equal to 180, is that enough information to state that that's a parallelogram? All right, well, the answer to this one is no, all right, but the fact that those same side interior angles are supplementary does at least prove, all right, that these two sides are parallel, all right? While that's not enough to state that it's a parallelogram, it is something to kind of keep in mind that same side interior angles will still prove sides to be parallel, all right? But still, this is a no. All right, let's try the next one. So what if we were given that AE is congruent to EC and that DE is congruent to EB, all right? Is that enough information to state that that's a parallelogram? This one's a yes, and that's because the diagonals bisect each other, and we know that if the diagonals bisect each other, then it has to be a parallelogram, okay? All right, let's just do one more. For G, AD is congruent to BC, but we're also given that AD is parallel, all right, to BC. And if that's the case, this is yes for that last reason where you have one set of opposite sides that are both congruent and parallel. And so that is enough to state, all right, that it's a parallelogram. If you did H on your own, it is a no, all right. It was only proving that one of the diagonals was bisected, not both of them, okay? Okay, so if we look at this next one, it says determine the value of A and B so that the quadrilateral is a parallelogram. All right, so what we are doing is we are assuming, all right, that this is a parallelogram, okay? Now, I'm not going to do all of these. I'm going to do the first one. So if I want this to be a parallelogram, all right, and I'm given these angles, what we need to do is look at what's the connection between the angles that we have. So if it's a parallelogram, what do we know about opposite angles? Well, we know that the opposite angles have to be congruent. So what I'm going to do is I'm going to set 7x equal to 56. And then I'm going to set 4y plus 4 equal to 5y minus 26. And then I'm going to solve. Okay. So setting 7x equal to 56, you get x is equal to 8. All right. Nice and easy. Now we're going to set 4y plus 4 equal to 5y minus 26. And so then if I solve, I'm going to subtract the 5y. I'm going to subtract the 4. So I'm going to get negative 1y is equal to negative 30, which means that y is equal to 30. Okay? Now, the next one is very similar to it. All right, you just have to set the opposite sides congruent. So I'm not going to do this one, but I am going to look at this quadrilateral FIHG. And I'm going to assume that it is a parallelogram, all right? And once again, I know it's not notated because I made this in GeoGebra, all right, but these are all angles, okay? So if you look at this prompt real quick, guys, all right, what do we know about the angles? Well, we know opposite angles are congruent, but we also know that same side interior are supplementary, or consecutive are supplementary, okay? So I'm going to look at my opposite angles, and I'm going to look at the 15A and the B, all right? And I'm going to set those equal to one another because I know that they do have to be equal. So I'm going to do 15A is equal to B. And what we can see is that is not helpful for us. All right, that leads us to nowhere. So maybe let's try setting up another equation. All right, and this time I'm going to look at 6A plus B and the B and ask myself, well, what type of angles are those? Well, those are consecutive. And I know that consecutive angles in a parallelogram are supplementary. So I'm going to do 6A plus B has to equal 180 degrees. So solving this, all right, I'm going to get 6A plus 2B, or simplifying, is equal to 180. And so then I'm going to focus on this equation and this equation and ask myself, well, how can I use those in order to get only one variable? And what I'm looking at is the fact that 15A is equal to B. So couldn't I take this 15A and plug it in for that B in my second equation? Remember, this is systems of equations. So what I'm going to get is 6A plus 2 times 15A. And that's going to be equal to 180. And I'm going to solve for A. Okay. So I'm going to get 6A plus 30A is equal to 180, which means that 36a is equal to 180. And then if I solve that, all right, I'm going to get a is equal to 5. Okay. So I'm not done yet because I have to find a and b. All right, so I'm going to take that 5, though, and I can plug it into either equation, but it's going to be easiest to plug it into that a right there. So I'm going to have b is equal to 15 times 5, which means that b is equal to 75. All right, so my final answer here is b is equal to 75 and a is equal to 5. Okay? All right, now let's do the last one. So if we look at this, so I made this in GeoGebra, and this right here is actually a squared. All right, just to keep that in mind, okay? So I'm talking about diagonals here, and because I'm talking about the diagonals, I know that in a parallelogram, the diagonals have to bisect each other, all right, which means that E has to be the midpoint of both of these diagonals, all right, which means that I'm going to take a squared, and I'm going to set that equal to 5a minus 6, okay? So that probably doesn't seem super helpful. But what we can do is we can recognize that this is a quadratic, and when we're solving quadratics, we have to have it set equal to 0. So I'm going to subtract the 5a over, add the 6, and I'm going to get a squared minus 5a, all right, plus 6 is equal to 0. All right. And I always like to keep the a squared positive. That's why I didn't subtract that over, and that's why I subtracted the 5a and added the 6 over. And so what I'm going to have to do is I'm going to have to factor this, guys, all right? So I'm going to look for two numbers that multiply to get that positive 6, but add to get the negative 5, all right? And this has been a long time, but those two numbers are going to be negative 3 and negative 2. All right, negative 3 and negative 2 multiply to get 6. All right, negative 3 and negative 2 add to get negative 5. So those are my magic numbers, okay? So what I'm going to get is I'm going to get a minus 3 and a minus 2 is equal to 0. And then you set them both equal to that 0 and solve. So you'd get a minus 3 is equal to 0, which means a is equal to 3. And you'd get a minus 2 is equal to 0, which means that a is equal to 2. And then if you double check those guys, all right, they're both gonna work. So I'm gonna get a is equal to 3 and a is equal to 2 for my final answer. Okay. All right. So I'm gonna pause there.